Good evening. We start with the concept of maxima and minima. A function f is said to have a local maximum at x equal to c. We already discussed this. If f dash of c equal to 0 and f double dash of c is less than 0, a function f is said to have a local minimum at x equal to c if f dash of c is 0 and f double dash of c is greater than 0. Now this is called as second derivative test. This can be applied easily. Now if second derivative is 0, then this test fails. So in this case, we have to apply the first derivative test. What is that? First derivative test. A function f is said to have local maximum at x equal to c if f dash of c equal to 0, f dash of c minus h greater than 0 and f dash of c plus h less than 0. Now the function will have local minimum at x equal to c if f dash of c equal to 0, f dash of c minus h is less than 0 and f dash of c plus h is greater than 0. What is h? H is a very small but positive number. In exam, we are going to use second derivative test only because, as I said, we can apply it easily. But for the first sum, we will be using both the tests, first derivative as well as second derivative test. So we start with sum number 8, first part. So what is that sum? Examine the following functions for maxima and minima. We begin with first one. What is f of x? It is 2x cube minus 21x square plus 36x minus 20. Let me explain. I'll give time for writing. So the first step is find f dash of x. It is what? 6x square minus 42x plus 36. What is f double dash of x? It is 12x or 18x. I'm sorry. This should be what? This should be 12x, not 18x. So this should be 12x, okay, minus 42. Now f dash of x equal to 0 gives what? 6x square minus 42x plus 36. Okay. Now if you solve this equation, first we will have to divide by 6 because we have to consider f dash of x equal to 0. So x square minus 7x plus 6 equal to 0. What are the factors? The factors are x minus 1, x minus 6. So we get two stationary points, x equal to 1 and x equal to 6. Now, first derivative test. Suppose h is very small positive number. What is f dash of x? It is 6 into x minus 1 into x minus 6. See this one, f dash of x. 6 into x minus 1, x minus 6. So for x equal to 1, tell me what is f dash of 1 minus h? Replace every x by 1 minus h. So that is 6 into 1 minus h minus 1 into 1 minus h minus 6. That is what? 6 into minus h into minus h minus 5. Take minus 1 common from both the brackets. So that gives you 6h into h plus 5. Note that h is very small, positive number. So definitely this product is positive. So f dash of 1 minus h is what? Greater than 0. What is f dash of 1 plus h? Replace every x by 1 plus h. So 6 into 1 plus h minus 1 into 1 plus h minus 6. So effectively this is what? 6 into h into h minus 5. H is very small positive number. So h minus 5 is definitely negative. H is positive. So the product is negative, that is less than 0. So you will notice that at x equal to 1, first derivative is 0 because x equal to 1 is a root of that equation only. F dash of 1 minus h is positive. F dash of 1 plus h is negative. And this happens only when the function has local maximum at x equal to 1. See, this is not standard short form. You have to write by first derivative test. Function has local maximum at x equal to 1. Okay, write down. Start writing. Okay, now for x equal to 6, tell me what happens. X equal to 6. What is f dash of 6 minus h? Tell me. See, you have to replace every x by 6 minus h. So this is 6 into 6 minus h minus 1 into what? 6 minus h minus 6. That is what? 6 into 6 minus 1 is 5. So 5 minus h into what? Into minus h. Okay. This is definitely negative. Why? This is not at all difficult. See, h is very small positive number. Okay. So 5 minus h is positive and minus h, as h is positive, minus h is negative. Plus into minus is minus. That is why I have written less than 0. Okay. Now, f dash of 6 plus h is what? 6 into 6 plus h minus 1 into what? 6 plus h minus 6. So this is nothing but 6 into 5 plus h, which is definitely positive, into what? Into h. Clearly, this is greater than 0. So after this you have to write, so by first derivative test, the function f has minimum at x equal to 6. Therefore, by, you have to write full form of this, by first derivative test, function has local minimum or just minimum at x equal to 6. Okay, good. Write this, and now we will be using second derivative test. Of course, you have to find the minimum value and maximum value also. How to find that? See, function has maximum at x equal to 6. I'm sorry, minimum at f equal to 6. So f of 6 is the minimum value. Function has maximum at x equal to 1. So f of 1 is maximum value. Okay. So I will write, therefore f minimum is f of 6. Replace every x by 6 in the function. Tell me which value you get. It is 2 into 6 cube, okay, minus 21 into 6 square. Remember, this is value of the function at that point, plus 36 into 6, okay, minus 20. So this is nothing but, you have to find the value. I will say also, this we are supposed to find f max is f of 1. Now as this is f of 1, I will write answer directly. So this is 2, 1 cube is 1, 2 minus 21, okay, plus 36 minus 20, which is I think minus 3. Okay. So you have to tell me f minimum. Yes. Type your answer in chat box. F minimum. Somebody is saying minus 128. Check this answer. Minus 128. Now in exam, we will be using second derivative test only. If it is mentioned, which is usually not, that find derivative, rather find the answer using first derivative test. So we will be using first derivative test in that case only, but usually it is not mentioned. Okay, So what is f double dash of x here? 12x minus 42. Then you have to consider first value. What is f double dash of 1? Because there are two roots, 1 and 6. So it is 12 into 1 minus 42, which is what? Minus 30, less than 0. Okay. Immediately you have to say, therefore, by second derivative test, don't write SDT, you will get 0 for that. You have to say by second derivative test, function has maximum at x equal to 1. Of course, you have to find maximum value of the function. Find out that function has maximum at x equal to 1. So f max is nothing but f of 1. We have already obtained that, so I will write it directly. So what is f max? It is minus 3. Now consider other point. So f double dash of 6 is what? 12 into 6, okay, minus 42, which is what? 72 minus 42, that is 30, which is greater than 0. So the function has minimum. Aditya is saying, sir, minus 30 पाहिजे ना. मी -30च लिहिलं बेटा. अरे इथे -3 येणार ना, नाही लक्षात येते आदित्य. सी this is second derivative at 1, which is -30. See, we've just checked second derivative to examine whether it is maximum or minimum. Once we come to know that function has maximum at x equal to 1, what is maximum value of the function? See, this is not function, this is second derivative. What is function? It is 2x cube minus 21x square plus 36x minus 20. So its value at x equal to 1. Okay, we already obtained it. So it is not minus 30, it is minus 3 only. Okay, good. Now find out. So you have to say, therefore, by second derivative test, function has minimum at x equal to 6. Okay, find out. In fact, we have already obtained, that is why I am writing it directly. So what is f minimum? See, this is not the value of first derivative or second derivative, it is value of the function. So it is minus 120. Okay, now while writing final answer, see how we can write the final answer. Final answer is max at 1 comma minus 3 and minimum at 6 comma minus 128. See, why can I write this as an ordered pair? Because function is what? Y equal to fx. So value of fx is nothing but value of y at which point? At say x equal to 1 or x equal to 6. Now second sum, f of x is x square plus 16 by x square. Find out f dash of x and f double dash of x. What will be f double dash of x? F double dash of x, derivative of 2x is 2, minus 32 is constant. I will write this directly. What is derivative of 1 upon x cube? Basically it is x raised to minus 3. Its derivative is minus 3 into x raised to minus 4. So second derivative is nothing but 2 plus 96 upon x raised to 4. Okay. Now after this, which is the next step? We solve the equation. See, you should have read that PDF file. So all the rules and procedure is given to obtain or to examine the discuss the function for maximum or minimum value. So the second step is solve the equation f dash of x equal to 0. Tell me what are the roots. So it is what? 2x minus 32 upon x cube equal to 0. So multiply throughout by x cube. So I will directly write x raised to 4 minus 16 equal to 0. So x raised to 4 equal to 16. Okay. So I can directly say x equal to plus minus 2. So x equal to what? Plus or minus 2. Now consider these values one by one. So I will say f double dash of minus 2. What is f double dash of minus 2? It is 2 plus 96 upon minus 2 raised to 4. Actually, you need not find this. You can directly say this is positive. But in exam, it is better that we find this 96 upon 6. Rather 96 upon 16, which is 6. So 6 plus 2, that is 8, which is greater than 0. And therefore, in the next step, you have to say, therefore, by second derivative test, function has minimum at x equal to what? Minus 2. And tell me what is the minimum value of the function. See, I'm asking minimum value of the function. Don't say it is 8. This is value of second derivative. So I will say f minimum is f of minus 2. Replace every x in the function by minus 2. Okay. So what is f of minus 2? It is minus 2 square plus what? 16 upon minus 2 square again. So this is 4 plus 4, that is 8. Okay, good. Now I will ask you to draw the graph of this. After the lecture, try to draw the graph of this function and check whether function really possesses extreme values at these points. What is f double dash of 2? It is 2 plus 96 upon 2 raised to 4. Same. So 2 plus 6, that is 8, greater than 0. Therefore, by second derivative test, function has minimum at what? At x equal to 2. And what will be f min? F min is nothing but f of 2, which is what? 2 square plus 16 upon 2 square, that is 4 plus 4, which is nothing but 8. Okay, so this is the final answer right now. So the next function is log x upon x. So what is f dash of x? You have to use quotient rule. Tell me the derivative. Okay, somebody is asking दोन्ही minimum कशा असतील. See, possible आहे. That is why I am asking you to draw the graph. आज तुम्ही जरा ट्राय करा. उद्या मी त्याचा ग्राफ पण तुम्हाला सांगेन आणि त्या पॉइंट्स ना तुमच्या असं लक्षात येईल. सी दिस इज लोकल मिनिमम. आय एम नॉट सेइंग दिस इज द लीस्ट व्हॅल्यू. So in that neighborhood of both 2 and minus 2, the function has minimum value at that particular point. Okay, so tell me, what is f dash of x? I'll write f dash of x here. So by quotient rule, I will write derivative directly. X into derivative of log x, which is 1 upon x, minus log x into derivative of x, which is 1 upon x square. Okay, so what is f dash of x? It is 1 minus log x, 1 minus log x upon x square. Okay, now it is better we find f double dash of x also. So what is f double dash of x? It is x square into derivative of 1 minus log x, which is what? Minus 1 upon x, minus numerator 1 minus log x into derivative of x square, denominator, which is 2x, upon what? Upon x square square, that is x raised to 4. See, I will not simplify this. Reason you will come to know afterwards. So I will just say this is what? Minus x, then minus 1 minus log x into 2x as it is. Why? You will come to know later on. This is what? Second derivative. Write down this. Now solve the equation f dash of x equal to 0. Yes, Karthik. Find out f dash of x equal to 0. So f dash of x equal to 0 gives, what does it give? 1 minus log x upon x square equal to 0. That is what? 1 minus log x is 0, and therefore I have kept 1 minus log x as it is, because when we find derivative, we will just say this is 0. That's it. Okay. So solve this equation. So 1 minus log x equal to 0. Therefore, log x, what is base of logarithm? E. Log x to the base e equal to 1. And therefore, x equal to e. Now we have to verify whether the function has maximum or minimum at this point. So for that, we will have to find f double dash of e. Let me explain. What is f double dash of e? It will be, see, minus e minus 0 directly. Why? Because x equal to e is root of which equation? 1 minus log x equal to 0. So here for 1 minus log x, I can directly write 0 at x equal to e. Okay. Upon, what is denominator? It is e raised to 4. Now tell me whether it is positive or negative. It is definitely negative. It is actually minus 1 upon e cube. I have to say this is less than 0. Okay. Therefore, by second derivative test, function has maximum, okay, at x equal to e. And what is that maximum value? We have to find that value also. Find out f maximum. So by second derivative test, function has maximum at x equal to e. And what is f max? It is f of e, which is log e upon e, but log e is 1. So 1 upon e is the final answer. Now next sum, divide the number 20 into two parts such that sum of their squares is minimum. Okay. Now we are interested in considering function in one variable, that is univariate. Don't say x and y be the two parts, or even if you say, then you have to say total is 20. So x plus y equal to 20. So what is y? 20 minus x. Okay. So write the solution. Sum number 9. Just let me check whether it is sum number 9 only or not. Let me check. Yes, right now. Let the first part of 20 be x. Let the first part of 20 be x. Therefore, therefore, second part equal to 20 minus x. Second part equal to 20 minus x. Therefore, therefore, sum of the squares, sum of the squares equal to, tell me what, x square plus, see on the screen, 20 minus x bracket square. You can keep this as it is or just expand, because many students, they cannot find derivative of 20 minus x square correctly. It is actually 2 into 20 minus x into minus 1, derivative of 20 minus x. So it is better that we expand this. So 400 minus 40x plus x square. So finally it is what? 2x square minus 40x plus 400. So this is the word problem. So in this case also, we find the function to be examined for maximum or minimum value. So after writing that, say let that function be fx. म्हणजे आधी हे सम असं विचारलं गेलं असतं, examine the function f of x equal to 2x square minus 40x plus 400 for extreme value, right? When a word problem hai, so we converted that into functional form. Okay, so next part is similar. Find out first and second derivatives. What is f dash of x? I will write it directly, 4x minus 40. What is f double dash of x? It is 4. Now I will ask you one question. Please listen to me. See, f double dash of x is always positive. You can put x equal to 1, positive, x equal to 20, positive. So function possesses minimum at all values of x. Is this statement correct? I repeat this. See, second derivative comes out to be 4. Means you can put any value to x. You will always get second derivative as positive number. So by second derivative test, the function has always minimum. So can I conclude that function possesses minimum at all the values? No. The main criterion is first derivative should be 0 at that point. And at that point, if second derivative is positive, function has minimum. Okay. So let f double dash of x be 4 as it is. Now, f dash of x equal to 0 gives 4x minus 40 equal to 0, that is x equal to 10. And you have to say f double dash of 10 and f double dash of 10 is 4, which is greater than 0. Therefore, by second derivative test, function has minimum, write down, function has minimum, underline this word, minimum at x equal to 10. So if the first part is 10, what should be the second part? 20 minus 10, that is 10. So two parts should be 10 and 10. Below that you can write the note. So for minimum sum of the squares, numbers should be equal. This is our observation. Right now. So it is better if you write two parts are 10 and 10. Note, two parts are equal. So the conclusion is, for minimum sum of the squares, two parts must be same. Now sum number 10. A wire of length 36 meter is bent in the form of a rectangle. Find its dimensions if the area of the rectangle is maximum. Okay. So Write down solution. Let x meter be the length. Let x meter be the length and y meter be the breadth of rectangle. Y meter be the breadth of rectangle. Then see, wire is bent to form a rectangle, right? Then its perimeter is, see on the screen, is what? 2 times in bracket length plus breadth. So 2 into x plus y, which is length of the wire, that is 36. So what is x plus y? 18. So what is y? 18 minus x. Remember, this is word problem. So using given information, you have to express one variable in terms of other. Initially, there were two, length and breadth. But here we have expressed breadth in terms of length. Okay. Now tell me which function is to be examined for maximum area. Okay. So write down. Therefore, area of rectangle is length into breadth, that is xy. But what is y? Y is 18 minus x. So this is nothing but 18x minus x square. Now the function to be examined should be denoted by f of x. Okay. So this is f of x. Right now. Rest part is simple. Find out f dash of x and so on. F dash of x equal to 0 gives what? It gives me x equal to 9. Now at that point, what is second derivative? Second derivative is minus 2 at all the points. So it is minus 2 at x equal to 9 also. Okay. So I have to say by second derivative test, function has maximum, function has maximum at which point? At x equal to 9. So for maximum area, length should be 9 meter. And what about breadth? Same, 9 meter. So the conclusion is for maximum area of rectangle, length must be equal to breadth. That is, rectangle must be a square. So 9 meter. So for maximum area, rectangle should be square. Write down. You can use the following results for CET. Write down. Amongst the rectangles, write down, amongst the rectangles with given perimeter, amongst the rectangles with given perimeter, square has the greatest area. Square has the greatest area. So if such type of question is asked, you can directly write the answer. Okay, I'll repeat this statement. Amongst the rectangles with given perimeter, perimeter is given, then square has the greatest area. So this is the first statement. Right? Second statement also. Amongst the rectangles with given area. Second statement. Amongst the rectangles with given area, square has the least perimeter. Square has the least perimeter. Okay, good. Now we will solve some number. Which one? Now sum number 11. Okay, sum number 11. What is that? A ball is thrown in the air. Its height at any time t is given by h equal to 3 plus 14t minus 5t square. Find the maximum height it can reach. One thing is clear, you had done this in physics, that at maximum height, what will be the velocity? Velocity will be 0. But what is velocity? It is rate of change of displacement with respect to time. In this case, dh dt. Okay, so write down. Here, write down. H equal to, it is given 3 plus 14t minus what? 5t square. Okay. So dh dt, that is velocity, it is 14 minus 10t. What is derivative of dh dt? It is d2h by dt square. It is nothing but minus 10. For, or I should say, at maximum height attained by that ball, at maximum height, velocity equal to 0. That is, dh dt should be 0. Therefore, 14 minus 10t equal to 0. So tell me what is t? It is 14 by 10, or you can say 7 by 5. Now check whether second derivative at this point is positive or negative. So at this point, d2h by dt square is what? Minus 10, less than 0. So by second derivative test, function has local maximum at t equal to what? 7 by 5. Now what is asked? Find the maximum height the ball can reach. So we are asked to find actually value of the function at t equal to what? 7 by 5. So find out. But before that, you have to say, therefore, by second derivative test, function has maximum at what? At x equal to, not x, I'm sorry, variable here is time, t, at t equal to 7 upon 5. Now you have to tell me value of the function at this point. So maximum value of h equal to, it will be what? 3 plus 14 into 7 by 5 minus 5 into 7 by 5 bracket square. Now simplify this and tell me what is the final answer. So that is the maximum height the ball can reach. Just type your answer in chat box. Yes, correct. 12.8 unit. See, if it is terminating decimal, write as, write in decimal, otherwise write as a rational number.